So in number 59 from section 5.1, we need to show that this equation is not an identity. That means we need to find one counterexample, or one example, one value of, find one value of theta that makes this equation false. So there's a couple different strategies to try to find that one value. One of them is to think logically. Why this would or would not be true, and maybe that will kind of help you think about what might not work and why wouldn't it work. Another strategy that might work is by thinking about the graphs. You could even graph each of them and look at the graphs and see how they match up or where they don't match, and then your counterexample can be one of those points where it doesn't match. I'm going to try something different, and I'm going to try the third strategy, which is try some values and check it. So kind of like a guess and check kind of deal. So I'm going to write that actually, guess and check. And if I get lucky and find one that's false, then that proves it's not an identity, because it's not always true. Even if it's true for some, if I can find one where it's not true, then I've proven it's not an identity. So the best strategy with number 3 is to find some numbers that are easy to evaluate. So like with this one, I know sine of 0 is really easy. So I'm going to try this. What if we let theta equal 0? Then I would have sine of 0 plus pi over 3. And my question is it going to equal sine of 0 plus, whoops, looks like I forgot a sign in front. Sorry, fix that little typo. I just had forgotten to write that word sign in there when I transcribed this problem. So that is fixed now. So back to doing the problem, which is sine of 0 equal to sine of pi over 3. So sine of 0, sine of 0 plus pi over 3 is just sine of pi over 3, which equals radical 3 over 2. And on the right side, I have sine of 0, which is 0, and sine of pi over 3, which is radical 3 over 2. Radical 3 over 2. I see these are equal, which means I have not found a counterexample. This is an example of when it's true. So this does not work as a counterexample. That doesn't prove that it's an identity. It doesn't prove that it's always true. It just means I haven't found a counterexample yet. So I'm going to try another one. So let's try something else that's also easy to calculate. And let's see. Let's do, like, what if I make this whole thing pi? So what if I let theta equal 2 pi over 3? Then I have sine of 2 pi over 3 plus pi over 3. And I want to know if that is going to equal sine of 2 pi over 3 plus sine of pi over 3. So on the left, I have sine of pi. 2/3 pi plus 1/3 pi equals pi. And sine of pi is 0. And on the right-hand side, I have sine of 2 pi over 3, which gives me radical 3 over 2. And sine of pi over 3, which also gives me radical 3 over 2. And that gives me a total of radical 3 divided by 2 plus radical 3 over 2 gives me radical 3. And that is not equal to 0. So this is a counterexample. That shows this original equation is not an identity. So I tried one easy number, it didn't work, so I tried another one. And I was able to do it on that second try.